Okay, everybody. So here is Cesium-137. I just got this on Wikipedia, and it's inside this container, I think. I'm not really sure if it's metal or what it kind of looks like in the real world. But in any case, it's a radioactive substance, and it's inside here in this container, right? Yeah, and it was responsible for the Chernobyl nuclear meltdown in Belarus. Yeah, so what I want to do is look here. I'm just going to do a really silly drawing of cesium. Okay, here it is. Right, here's our cesium, 3,000 grams. By the way, that is 3 kilograms because 1 kilogram is 1,000 grams. So here's 3 kilograms. And a kilogram is roughly 2 pounds, so it's kind of like 6 pounds of sugar, that type of weight. So that's now. This is how much we have now. And after one half-life, now if we think about half-lives, after one half-life, we're going to have half of it remaining, and half of it will have decayed. And if you think about years, that's in 30 years' time. In 30 years' time, half of this will have decayed, so we'll have half of it left. Now, does that kind of make sense? In 2 half-lives' time, we've got half of the remaining amount, right? So this is like the whole amount, and then we have half of it remaining, and then a quarter remaining. And each half-life is 30 years. That means in 60 years' time, that's 2 half-lives, we've got a quarter remaining. Now, somebody give me the next line. Walk me through it. In how many years' time are we going to have, will it be the third half-life, and what will be remaining? 90 years. Beautiful. And what do we have over here? 1/8. Yes, because it's a half of a quarter. 1/8. Beautiful. Just for fun, do another one. The next line is going to be 4 half-lives. What does that look like? 120 years' time. Perfect. And how much remains? Yes, 1/16. So half of this is remaining, 1/16. And that's how it goes. But this is the basic concept. Do we get that? Is that clear? So once we get that, and now we'll start sticking some numbers in, right? So let me see. Would it be smart to do this? Just kind of go over here, put that there, and start writing stuff. So what we're interested in is kind of the amount remaining, right? So let me just do this. I'm just going to grab some tape. Okay, so 30 years, 1 half-life, it kind of looks like this. And what's the amount and so on, right? Okay, so we start with 3,000. Let's just keep it in grams. That's cool. We could do 3 kilograms if you want to, but it doesn't matter. Let's do it in grams. So that's small g for grams, right? So this is now like year 0, no half-lives. Now we've got 3,000 grams, right? In 30 years' time, that's 1 half-life. We're going to have half of it remaining. How much will that be? Fill that out. Yep. Yep. Yeah, 3,000 and subtract half, but do a division at least. 3,000, why do I do? There you go. So you can do 3, to get half of 3,000, you can divide it by 2. Just because I want to come up with a formula, I want you all to get half of a 3,000 by multiplying it by something. Can you get half of 3,000 by multiplying it by something? Multiplied by what? 3,000 times what will give you half of it? And then students tell me, oh, we don't need fractions in the real world. Oh, yeah, do. It's 3,000 times a half, isn't it? No? Right. Yeah, or 0.5. Yep. 3,000 times a half or 3,000 times 0.5, that will give to you, right? So there's lots of ways of getting half of 3,000. So in other words, we all agree that in 30 years' time, that's one half-life. We've got half of it remaining. That's 1,500 grams, right? Okay. Now, in 60 years' time, that's two half-lives. We have a quarter of it remaining. So what is it in grams? What does it look like in grams? Yeah, you can do 1,500 over 2. That's one way of doing it. I'm going to guide you towards multiplying by something because I want to come up with a formula. It's just a cool way of getting the formula. Yeah, like you can do 50 times a half. Yeah, or 0.5. Yeah, that's one way. Yep. Yeah, yeah. Yeah. Yeah, yeah. So 1,500 times a half, or half of 1,500 is definitely going to be 750 grams. So we agree with that. But the problem is we're going to be asked, for if it's 42 years time, or if it's so again, the reason I'm going through this is to try to come up with a formula. So I'm just to give you all a heads up, we're going to be asked, okay, for 109 years, how much is left, or it could be for 7.8 half-lives, how much is left, or whatever. So if these numbers are not nice, then what do we do, right? So we're trying to figure out a formula. So what I want you to think about is 3,000 times what will give 750. You know what I mean? 3,000 times what gives 750. Can you figure that one out? Well, let's do it this way. 3,000 times a half gives what? And what happens if I multiply it by a half again? Yeah. So 3,000 times a half gives 750. And we can also write that with exponents, right? 3,000 times a half to the power of 2 gives us 750 grams, right? So I'm sorry for going all the way around, everybody, but I just want to say there's lots of ways of doing it. It's just that the reason I like this way, and I hope you'll see, is it'll really help figure out a formula so that if you're asked for, if you want to figure it out for, let's say, 10 half-lives or H half-lives, which we will in a minute, 10 or H half-lives, then we can follow the same pattern, right? So in any case, figure it out for 3, and then I also want you to come up with a cool little kind of formula way of writing it, right? So take your time, figure it out for 3, and tell me what you get. Good, yeah. 3, it should be 375, because it's just, you take the previous amount, 750 grams divided by 2, and it should be 375 grams. So we know that, that's good. Now the question is, right. So the cool way of doing it again is, 3,000 times a half gives 1,500, times a half again gives 750, times a half again gives 375, right? And the cool way of writing that with exponents is this: 3,000 times a half to the power of 3. And that gives the 375, right? Okay. What's that? Yeah, because now we can see a pattern. when we had 2 half-lives, it was a half squared, wasn't it? When you have 3 half-lives, it was a half cubed. So what I want you all to do is figure out if you have 4 half-lives, what's remaining. Yeah, so go ahead and just do 4 half-lives. What would it be? And can we follow our cool little formula we found here? 187.5. That sounds right. So would it be 3,000 times a half to the power of 4? Lovely. So 4 half-lives, that becomes a 4, right? In the calculator understands PEMDAS. So, yeah, we'll do that in a second. We'll do calculator in a second. I just want to do 10 half-lives now. So what would it look like for 10 half-lives? Right. So, good. So 3,000 times a half to the power of 10. Agreed? Oh, good. And now do H half-lives. For H half-lives. Yep. Yep. 3,000 times a half, or 0.5 to the power of H. Perfect. Yep. Cool. Yeah, so cool. Absolutely. Let's go wild now. Why not do 100 years? Okay, so what happens if you've got you want to get the half-lives for 100 years? So not year. Oh, years. Sorry. Yeah, you're saying. Oh, no, sorry. So yeah, it's going to be years in a minute. Yeah, we'll look at that in a sec. Yeah. So one thing I just want to point out is, in your calculator, a half, I hope everybody knows, is 0.5. So, like, in your calculator, to get 3,000 times a half to the power of 4, you just type this, 3,000 times with a star, and then you can just go 0.5 to the power of 4, right? And, let me just, and for 10, it's the same thing. So, 3,000 times 0.5. Power is that little hat button. It's on the top left here. To the power of 4. And then press enter. Right? You can also go 3,000, maybe parenthesis, 1 over 2. To the power of 4. That will also give 187.5 grams, which that's what that one was. 187.5 grams. And to the power of 10, look, I'm just going to go up with my arrow, going to grab that, going to go across with the arrow, type in 10, and then press enter. And I get 2.9. I'm just going to call that roughly 3 grams, rounded to the nearest whole gram, right? Yeah. And so the formula is that the amount, like A, is equal to 3,000 times a half to the power of H, right? Yeah. So that for any half-life, we can figure out the amount, right? Now, the only thing is they might give us the years, and that's the next thing to look. So if they give us the years, we then have to convert years into half-lives and so on, right? So I just want to give you an easy number of years just for fun to practice. If I gave you 45 years, how many half-lives is that? Take your time. How would you think about, how would I figure that out, right? 45 years is how many half-lives? Well, let me ask you this. If you think about it, 45, what do you, just take a guess off the top of your head what it is. Just what does it make sense to be? What do you think it is? Like, just take a guess. Yeah, take a guess. Just look at this and take a guess. In between what and what? Ah, nice. In between the 1 and the 2. Good. So should it look like something like, maybe it looks like 1 point something? 1.5 is a really good guess. Yeah. Because, watch this. what's this magic? If I take my 45 and I divide by the half-life of cesium, 30. If I divide by 30, what do I get? 45 over 30. Over 30? 1.5. Yeah, and that makes sense because 45 is literally halfway between 30 and 60, right? So it is 1.5. Does that one kind of make sense? Right. So 120 years, by the way, was 4 half-lives. Look at that. So just for fun, everybody, do this. Go 120 and divide that by 30, and what do you get? 4. Yeah, 4. See, 90. How do I turn 90 into 3? What do I do to 90 to get 3? Right, 90 over 30. Right. So dividing by the actual, what the half-life is, 30, that's how you convert years into half-lives. You divide by how long a half-life is, right? Look, 60 over 30 gives what? 60 over 30 is 2, right? So that means if somebody said, well, okay, so we've got, 100 years. If somebody said, which in the question it is, how many, 100 years, right, is how many half-lives? We go 100 over what? Yes. Yep. Right. 100 over 30, yeah. Which is roughly, I'll just give it 2 decimal points, I guess. 3.33, right? Now it goes on forever, but roughly 3.33. And if we use that, we'll get close enough, right? So 100 years is about 3.33 half-lives. And think about it, I mean, once again, 100 years is in between 90 years and 120. So you would imagine it's 3 point something, right? Anyway, so then use your formula then. So what's the amount remaining? Well, we have a formula. Amount is 3,000 times a half to the power of the number of half-lives, right? Right. So what's the amount remaining then for 100 years? So the 3,000 times a half to the power of 3.33. Yep. Yeah. So I'm gonna, in a calculator, I'm gonna write that 3,000 times 0.5 to the power of 3.33, right? And you got what roughly? I'll just stick it in, I guess. Yeah. Okay, 298.3. I'm going to say roughly 298 grams, right? Roughly 298 grams, okay? If you wanted to be extremely accurate, you could do this. 3,000 times 0.5, and don't round during your calculation. Like, just put in 100 over 30. See? And that way I'm not rounding in my calculation, which will throw off my answer a little bit, right? So that would be even better. So I'm using my arrows. I'm going to grab that. I'm going to go parenthesis 100 over 30, close parenthesis. Now press enter, right? And 297.6 would be more accurate, but it's still roughly 298 if I round up, right? So we're close enough on these. It's fine. So I'm not pushed about too much about the rounding. At least give it 2 decimal places. But yeah, this would be the best way of doing it for sure, because that's the most accurate. Because we didn't round and then calculate using that rounded number, right? Okay, so I can't help but throw another one out there. I'm going to ask you how much cesium is remaining after 1,000 years. So I just can't help asking another one just for practice. So after 1,000 years, what's the half-life and what's the remaining amount. So for 1,000 years, I want the half-life and I want the amount remaining. So off you go for a bit of practice. Take your time. What's that? Okay, step one, just figure out how many half-lives that is. What did you do for 100 or 120 or 90? What do we do to get, how do we, yeah. Yeah. Yep. Yep. Yeah, take your time. Yeah, so half-lives, we would just like the rest, just go 1,000. And how many 30s are contained in 1,000? Because each half-life is 30 years. So you're thinking how many 30s are contained in 1,000? And just round that to a couple of decimal points, that's fine. So 33.33. Right. And then, yeah. Right. And so for the amount, 3,000 times a half to the power of 33.33. Yeah. Okay. It sounds like it's gone, pretty much. It sounds like after 1,000 years, we've gotten rid of this stuff, hasn't it? Because watch, when we plug it in, 3,000 times 0.5 to the power of 33.33, it's almost gone. Look at that, 0. So there's a 6 zeros, isn't it? 6 zeros, 2, 7, 8, and that's grams, by the way. So that's like in grams. So I would say that after 1,000 years, this stuff is basically gone, isn't it? It has decayed into nothing. It's just a little, not even a little dot. Because a gram, 1 gram is like a grain of salt. Okay? So like you can't even see this. It's after 1,000 years, it's gone, basically. All right? Good job. And by the way, if I did that more accurately, it's not going to really change anything. It would just be, in here I go parenthesis 1,000 divided by 30, close parenthesis, then press enter, and it's just like 277 instead of 278. So, but again, it's for practical purposes, after 1,000 years, this cesium has disappeared completely, right? It's decayed so far.